students. Now, today class, I'm going to talk about two things. I would like to go back to that energy level to explain some things based on this energy level diagram. And I'll be able to explain three important meaning definition under that, three important parameters under that. Then I will also talk about the calculation under energy level. We're going to solve some questions. Then I will give you some to do on your own. So you are welcome to the class. Today, we're going to talk about the energy level diagram. You can see in the last class I tried to explain this, but I omitted some definition. I only explained how the electron can move from one energy level to another level. As you can see, look at this. I still make use of what? 7 electron volt because I'm in love with it, -7. But now, in this case, the one I explained in the last class, I talk about what? Increasing positive energy level. But today, I change it. I change it to what? Increasing negative energy level. But as you can see, this one, that's what we call energy level, energy level, energy level. I get that. So this energy level, which is n equal to 1, that n represents the quantum number, that is the quantum number of that energy level, the level of that, the number of that energy level. This is the second quantum number. So this should be third quantum number, and this should be what? N equal to 4. That is the fourth quantum number. So you can see another thing that we have n to infinity, and this represent the energy. I explained that to you. That is on the vertical arrow. Will indicate that the arrow can go up and the arrow can move down. It depends on the direction of the electron. But what I want to explain now, let me assume that I have electron here. I've talked about this in the last class. Then the electron move from here to here. What will happen to this electron? This electron will gain energy or absorb energy. That is what we call absorption spectrum. I get it now. But at the same time, the electron can be here. Then I do the electron is already in the quantum number 3, and when the electron move back to this place, what will happen? That means this electron will lose energy. We emitted energy. I get you now. And that's what we call emission spectrum. Now, but another thing I want to explain to you, this, if you have this, let's assume you have electron here, and this electron move directly to this. Let me draw this for you to know. This is to infinity. So this electron move directly down to here. I get it. I will call it to infinity. That means this electron move to the infinity. That is what we call ionized electron. I get it now. And in that state is what we call ionization state. I get it now. Now, but you can see all started from the ground state. This is the ground state. So you can first of all write the definition of the ground state. Ground state is the energy, is the lowest energy level an electron can have in an atom. What I call it is the lowest energy level an electron can have in an atom. How you get what I'm trying to? So that is what we call energy level. You can see it here. You can see that ground state is the lowest energy level an atom, an electron can have in the ground state. I get an electron can have. That is when you're talking about the ground state. So let's move on. You can write the first energy level after the ground state is called first excitation state. Full stop. Let me explain that. Now look at this. This is what we call ground state. I get it. That is the most stable state. I get it. So now after this ground state we have N2. This N2 is what we call first excitation state. The third one is what we call second excitation state. Like that, until it now reach what? Excitation, ionization state. Do you get that? Now paragraph. Let's bring out this excitation state out. We have different excitation state. It could be first excitation state, second excitation state, third excitation. But let's write on that excitation energy. Excitation energy is the energy required to raise an atom from its ground state to an excitation state. That is the energy required to raise an atom from the ground state to an excitation state. Full stop. Mathematically given by mathematically given by this. Mathematically given by this, but I don't want to rub off the board for now. We have E equal to what? Electron volts. But in this formula now, this E is an energy. That should not be what? The excitation state, and normally denoted by X. Then this will not be the potential. I get to an excitation potential energy. I will also represent which one? With X. So that is when you're talking about the excitation state. You can say where EX, in this case, that should be equal to what? Excitation energy. And Vx should now be equal to excitation potential. So let's move on paragraph. If the atom is in its most stable is in its most stable, that is ground state, and absorb an amount of energy, that is EV, amount of energy EV, which just remove an electron completely from the atom, that is V, is known as ionization potential of the atom. Full stop. So this will lead me to explain what we call ionization state. You can bring that one out. Ionization state. So ionization state, I normally denote it with what? With E, capital letter E I. Ionization state is the energy required to remove an electron completely from an atom in its most stable state or ground state. Can you see that now? Let me explain that to you. Look at it. You have an electron here. When this electron jump from here completely to the what? To infinity, this electron will not come back. I get it now. That means that electron has been ionized. It will not come back. But what happened that they are not telling that the energy required to remove this electron from its ground state is what we call ionization energy. Is that okay? So now I will try to go to the last aspect of this, which involves calculation, that we are going to do some together now, and I will give you some to do yourself. So let me try to run all this. Let's go to calculation of energy level. Let's see. Energy level. So let's see this. I think I have some question. That we can work on here. So let's see. But before we go to that place, let me just quickly explain. We talk about some formula. I think we talk about energy. We want to get the energy level of each E equal to minus E naught over n squared. You can still remember this. You can still record this. Then we still make mention of another formula. When you have this, can still be what? Change in E